Now that we have covered how to load the most common types of data within RMSP, I would like to cover some more details on visualization. Starting with 2D sections. So for instance, we can start with our grid. And then the function I would like to cover now is called section plot. This function takes a number of arguments. In this case, I'm gonna focus on the most important ones. So the first argument is variable. So if you have a variable that you want to visualize, you're gonna use this argument for that. The other thing that can be provided as a variable, in case you don't have a particular variable that you're interested in looking, you can use this argument to provide a color. So in our case, our grid is empty. There's no variable to visualize. What I would like to do instead is to provide a color. So there are many ways of providing colors within Python. One of the ways that I typically use for looking to grids in sections like this is to use a grayscale color map. So if you provide a float from 0.0 to 1, you can specify a grayscale. So if I provide 0.5, that's right in the middle, and that's gonna be a gray color. So the second argument is orient. So orient defines the orientation of the plane that is intersecting our data that we want to visualize. We can specify some angle to plot a rotated section, or we can use the coordinate axis to define that plane. So for instance, if I copy here, XY is going to be a plan view section, and I could look into some cross section as well. In this case, I'm going to look into YZ cross section. In terms of next argument that we have in here is coordinate. So you can provide a coordinate. So the plane that we are going to be plotting is going to have the rotation specified by the orient, and it will intersect this coordinate in the space. If you keep the coordinate as known, it's just gonna plot through the centroid of the object. But for instance, if you want to plot cross sections on multiple objects and make sure that the coordinate is the same, the cross section is the same, you will have to define a specific coordinate. So for now, I'll keep it as known. I'll just copy it in here. And we are going to look into the next argument. And the next argument here is tolerances. So in this case, tolerances have no impact on sections for grid, because we're going to be looking at the intersection between the plane and the grid. But tolerances can become important when you are plotting sections through point data like composites or mesh data, so that the tolerances is going to specify how much of the object around the coordinate that you want to see. Let's just copy this and place it in here. So these are the main arguments that I'm going to be covering with the section plot. So if I run this cell, it's going to generate a cross section on the middle of the grid, and just with a gray color. And this is a section of elevation and northing, just like specified on the orient argument. So I want to add elements to this section. So as you can see, the output of this call is a tuple of 3 objects. The first one is a figure handle. The second one is an axis handle. And the last one is return known here, but it is for the color bar. In this case, we do not have any color bar. That's why it's returned as known. So if I want to capture the outputs, I can do fig axis and C axis for the color bar axis and capture the output. So now this figure and this axis contain this section plot, and I can start adding elements to it. So the first element I would like to add is comps. So for this one, I'm gonna use section plot, but you will see also that we have section plot and we have section plot draw. So every time you see a plot underscore draw function within RMSB, that means that this is just drawing a extra element on a existing plot. So it's not gonna change the main properties of that plot. So that's what we want in here. So I'll do section plot draw, and the first argument of every underscore draw function is the axis, because it assumes there is an existing figure. So the axis being generated here, and I can just provide it down below. So now let's start populating. So you will see that we have some elements in here that are similar to the elements in there. And if we want to be looking at the same section, we are gonna have to use consistent arguments. So because we are gonna use arguments in multiple places, what is very useful to do is to create a variable for containing the section properties. So in this case, I'm gonna create a dictionary, which is gonna hold some of the arguments I'm gonna use everywhere. So the first one is the orient. So I want to use the same orient. And the second one, to guarantee that I'm looking at the correct same section, I'm gonna want to define coordinate. So that brings me to the next thing I need to do. So for instance, I know the coordinate that is being used for plotting just by looking at the title here, but I could also, for instance, check grid.spatial centroid, and that provides me the coordinate of the centroid, and you can see that the x coordinate of this section matches the coordinate I see in the title. But let's say I'm not going to use this exactly. I can use something such as 850. So that's going to be the coordinate I want to generate the plot for, using all the data that I'm going to add to this figure. So now what I can do, because I have specified these two arguments in this variable, I can replace that on my function using this star view. So this is just going to inject these arguments into this function call. And the nice thing about it is that I can use it for every object I'm adding to the figure. I discussed before that tolerances is not used within the grid section plot, but it's quite important for the composite section plot. So in this case, I'm going to add those tolerances in here. And let's say I want 25 meter tolerance around the section so that I can visualize composites even if they do not fall exactly on that cross section. So other thing that I want to specify for composites is the variable. So my composite actually has a variable. So the variable that is in this particular data set is copper. So I want to visualize copper. The next thing I want to add to this section is my topo. So let's do topo.section plot draw. You're gonna see that section plot and section plot draw, just like view 3D, is also available for all the spatial objects within RMSB. So we already know that we can plot the axis. We want to use the same view, and I want to specify tolerances for the mesh. In this case, I'm going to use the same as I used for the composites. Other arguments that I might consider that are very common for sections using wireframes is the trace color. In this case, I will specify K, which is the color letter for black. And I can also specify trace line with it, which is gonna be 1. So this is gonna add my topo to the cross section. And the last thing I would like to add to my cross section is my solid. I'm just gonna copy and paste, and I'm gonna change this to low shell, and everything in here is the same. For the color, I'm gonna use another color code, which is C1, which represents a orange color. I'll keep the trace line with it the same. And the last thing I would like to do within this plot is to add labels so we can create a legend. So let's do label equals, this is my grid, and let's do label equals composites. And here I'm gonna do label equals topo. And lastly, label equals to low shell. Just one detail here, because we are doing label of the traces, we need to be specific. So the variable for it is called trace underscore label. I will format my cells real quick. So there's an error. I have double parentheses here, so now it should be fine. All right, so I can now run this cell, and we are seeing all the elements that I have added to this plot. We see the topography, we see the grid, we see the composites, we see the solid. You might have noticed this shaded area around the solids in the topography. The reason we have that is because of the tolerances. Sometimes we just want to see the traces, so we can make the tolerances 0. So now I just see the traces. Other thing that I can do to this plot is to increase the size of the figure, and that's controlled by the first section plot call. So let's do fig size equals 8 by 8 and run again. So now the figure is a little bit bigger. Another thing is that we have added composites. The composites are colored by copper, but we don't see a color bar for copper here. And the reason we do not see the color bar is because copper is being added by a section plot draw, and section plot draw is not going to modify any axis of the existing figure. So in order to add a color bar, we have to make it a actual section plot. Axis is no longer the first argument, it's a keyword argument, so that we keep building on the existing figure. But this now will be allowed to make changes to the actual axis. So let's run this. So two things happened here. One thing is that copper was added to the color bar, and the other thing is that both x-axis limits and y-axis limits have changed. It's no longer defined by the grid, because my composites call come after the grid call. The composites is going to overwrite, so the limits are going to be based on the composites now. So another thing that I would like to demonstrate is how easy it is to change the views. Right now what we are doing is using an orientation equals YZ, and we are providing the X coordinate. One thing that we can do is actually provide the full set of coordinate, and I will explain why. So let's look again at the spatial centroid. Let's get the other two coordinates in here and make it a list. Remove some decimal places there that we don't need. So now we are specifying a full coordinate. The advantage of using a full coordinate is now that I can change the orientation here, and the slicing function will figure out the location of the slice just based on the full coordinate. So to see a plan view section, I can do XY, and this is now a plan view section that goes through the Z coordinate of 1122, and that's the Z coordinate here. If I change it to a long section, it will use the 12,268, which is the Y coordinate. So it figures out what's the coordinate that's being slicing the data. So let's go back to the YZ cross section. So this makes it very easy to update and make different sections on our data.